Good morning. Thanks for coming to this workshop about realizing the full potential of Web3. It's really about why we build Boba Network, and what Turing hybrid compute, which is only available on Boba, would help developers build more engaging, more interesting, more compelling Web3 applications. So let's go back in time a little bit, right, to the original creation of Ethereum. And a fundamental premise of Ethereum is that, while Bitcoin, which is a ledger, is good, if you can actually program it, it's even better. Computers are better. And our hypothesis is that, let's take it one step further, a more connected computer will lead to a more creative and powerful decentralized system. Just to give you an analogy, right? We all have a phone. And imagine creating mobile apps without the cloud, right? You're limited to what you can do on the device itself, and that's it. You can still build apps that run on the phone, but it's not nearly as interesting, right? And that's what we do here. So, we started with Bitcoin script, minimal stack-based programming language. It's really designed, it's very transaction-oriented, it's not Turing complete. And then Ethereum came along, breakthrough innovation, right? However, it is slow, as we all know. And there's a good reason for that. Ethereum wasn't designed to optimize for raw compute performance. It's designed to be a decentralized system, right? With thousands of uncoordinated nodes that could somehow come to agreement on something, and that's really hard. And in order to achieve that, there has to be a lot of limitations imposed on the kinds of computations that we can do. And for example, you can only do integer operations. Reason is, if you allow floating point operations, what if two computers are running on different CPUs and they arrive at slightly different answers? They won't be able to come to consensus. And so that's why Ethereum is slow, and the computational complexity is very limited, right? We can only do pretty basic computations. Can't even take the square root of a number and get a reasonably precise answer. But then L2s, layer 2s came along, and while the original motivation for creating layer 2s is to address the most obvious challenges of Ethereum, which is speed and throughput and cost, right? There's actually an additional major benefit, and that's enabling more complex computations. And that might seem a little bit counterintuitive. People don't think of layer 2s as delivering that kind of benefit, right? Most people think of layer 2s as, faster, cheaper, that's awesome. Let's just move our transactions to layer 2s. Well, the key difference, what is a layer 2? A layer 2 really is we're decomposing this monolithic layer called Ethereum that combines execution, settlement, and data availability all into one layer. We're taking the execution layer, separating that into its own layer, and we're calling that layer 2. And the key difference between layer 2 and layer 1 is that the layer 2 doesn't run its own consensus protocol, right? The whole point is that we rely on layer 1 for consensus, so that we don't need to do all the separating these two. Now suddenly, because of that, we don't need to worry about what it takes to ensure thousands or tens of thousands of computers would arrive at the same answer. Because layer 2s are only responsible for execution. And what does that mean? Right? It means we don't need to impose the same kinds of constraints on the kinds of computations you can do as you would need to on the layer 1. And that changes everything. Right? So on layer 2s, there's only a single sequencer that produces the blocks. It executes the transactions. And therefore, we thought, well, maybe we could use this to our advantage, to developers' advantage, to interact with the outside world, to call external APIs. And after a year's worth of work, we're able to overcome EVM's restrictions by by modifying Geth. So we have a customized version of Geth running on Boba network. It's called L2T, T for Turing, L2T Geth, with atomic support for generating random numbers and making any external API call that you specify, that you trust. And it's super simple to use, very easy. These are one-line calls. What you see on the screen is pseudocode, but like look at the first example, right? Turing get random. That's all you need to do to get a random number. Or in the second example, you specify the RPC endpoint that you want to call to, let's say, get the current quote for BTC USD pair. Boom, like one call and you're done. Now, how does it work? Right, so let's look behind the scenes a little bit. So our L2T Geth is the one that actually makes the external API call on behalf of your smart contract. Right, so it will intercept certain calls that have Turing calls embedded in them, and then call the off-chain API or RAND to generate a random number. And when the results come back, our Geth would replace the original call data with modified call data that includes the responses that come back from the off-chain call. And this is important because we need to ensure that these transactions can be verified afterwards by the fraud provers. We need to make sure that whatever we've done is fully compatible with the rest of the optimistic rollup architecture. And so we'll write both the original transaction and the modified call data that includes the off-chain API responses into Ethereum layer 1. And from that point on, everything is treated just as if it were a normal Geth transaction. And the key is only the sequencer would call the API, so no one else. Because if you let other independent nodes call the same API, you might not get the same results back, right? So it's important that only the sequencer makes the calls, and then once the layer 2 block is written back on layer 1, and the verifiers and the replicas will use the stored responses from the API call from the block to do their job. So here's a diagram that outlines how that works. Right. So step 1, L2T Geth would intercept the RPC. You would make an RPC call to the Geth, and our Geth would be like, okay, this is a Turing call. It is. It calls the endpoint that you have specified. Waits for the response to come back. If the response doesn't come back, it's going to time out. We've set the timeout currently at 1200 milliseconds. Right. So when you're writing around this, you want to have a graceful fallback default value in case the external API doesn't come back or takes too long. Right. So the response comes back. Our Geth would replace the original call data with updated input that includes the response that comes back from the off-chain call. Creates a new block and submits that to layer 1. And then the new block is indexed, replica does this work, the verifier does this work, everything else just works. It's taken us a while to roll this out on our mainnet because there's a lot of work that needed to happen under the hood. These are some of the changes that we needed to make, and so we modify ETHGlobal and modify the Ethereum block format to include the responses from off-chain APIs, and all of the data from off-chain APIs are written back to Ethereum layer 1. So as a result, we put a limit on the size of the response string that comes back. Because otherwise, these calls could become really expensive. And then we also added the ability for Geth to replay these compute requests based on the data that's written to Ethereum. We also modified a bunch of internal data types and finalized an sample and other parts of L2 Geth, miner, worker, Go. We also needed to modify all the services that pass data, right, from layer 2 to layer 1, how you index layer 1, how you inject layer 1 data into the layer 2 geth, and then we tested and tested and tested. Finally rolled out Turing on Rinkeby during ETH Denver, and then a month later made it live on Mainnet. And by now, developers have started building on Boba using Turing, and I'll give you some example use cases. For example, you can build DeFi protocols based on off-chain assets, right, such as real estate or some sort of bonds denominated in fiat and TradFi world. You can now start pulling these fiat world, real world assets into DeFi protocols. There's a team on building on Boba, creating an NFT lending protocol that uses an off-chain machine learning based valuation model to place, to put a valuation on these NFTs so that they can figure out how much to lend against these collaterals. Right? Imagine trying to do that all on chain. It's just impossible. It's too expensive, too slow. But now you get the best of both worlds. You might also want to decide to incentivize your community members to do certain things on social media, for example, right, to retweet, and you can use Turing to call Twitter to verify that, to see if someone has actually retweeted something, and after the verification, you can then automatically release or airdrop some rewards to these community members, right? And since it's all happening on layer 2, these transactions are much cheaper, much more affordable than if you were to do it right on layer 1. There are also DAO memberships, right? DAOs that want to connect their members' identity with the off-chain real-world identities. Now, to some of the Web3 natives, this might seem like a little weird, but if you think about how Web3 is growing and looping in more and more mainstream organizations into the movement, you start realizing there will be actually more and more demand to integrate what's happening on chain with what's happening or with what already exists off chain. For example, there are college alumni associations out there that are thinking about, how do we create NFTs that represent memberships in our alumni association and identify them as verified members in a metaverse that they're creating. So in that case, they're not really trying to create NFTs that can be flipped or traded. They're trying to use NFTs to represent an identity that exists in the real world that needs to be verified. Right? You don't want someone to fake themselves as a Harvard alumni. They're really not. So Turing also enables that. You can create NFTs that could be connected to the school's official alumni directory and verify the real world identity of that metaverse character. You can also create a Twitter activity-based token fountain. We've created this. We've created a Boba fountain on a Rinkeby. And you can also use our atomic random number generator for your NFTs. And the bottom line is, if we're able to connect this decentralized computer with the rest of the world, with other network computers, you can now create a lot more interesting applications. Right? And the list here is, we're just scratching the surface. Like, some of these ideas actually came from developers that started trying out Turing. So we've got a detailed write-up at this link, bit.ly/Turing, the capital T. It's really easy to use. It's just a one-line call. And what really sets us apart at Boba here is we're enabling developers to build smarter applications on Ethereum. We're not just scaling it in a traditional sense of making it faster and cheaper. We are augmenting Ethereum by enabling you to build applications that can include algorithms that are much more complex than what you can execute on Ethereum layer 1 itself. All right, so that's our hybrid compute story. It's live on Mainnet. Really encourage you to try it and see what you can build with it. A lot of developers are finding that this completely changes how they think about what they can build. It really expands the design space available to you, and yeah, I can't wait to see what comes out of this weekend's hackathon. Thank you. Questions? Yes.
Yeah. Just got a quick question about sort of. Yeah, no worries. I've got a quick question about, I don't know if it's working, but security. So you said that there was a time limit on requests coming back and having a valid response as well. Do you think it's possible that someone might want to overload the network with requests that might take too long, and that might slow down block times or transactions because of that? Is that something that's possible?
It is possible, which is why we put a time limit on it. But of course, we have no control over how quickly the external API comes back. And yeah, so it's a 1200 millisecond timeout. Fortunately, I mean, you get to control which APIs you call. And our hypothesis here is that the developers are only going to call, you're only going to call APIs that you trust. So these are either going to be your own RPC endpoints. If you're, let's say, in that NFT lending model, right? You're running your own off-chain valuation model. It's your own RPC endpoint. If it doesn't come back or it's too slow, you have full control over how you want to fix that. And in the case of calling Twitter or whatever, that is a more, much more established and trusted API. So that's less of an issue. Now, it is possible for a, let's say, a nefarious developer that really intentionally wanted to deploy a smart contract that calls some random API that just never comes back. That is possible, but fortunately we do control Geth in this case, right? We're the trusted party that operates a single sequencer. So if that's the case, we can filter that out.
That sounds good.
Yeah.
What other sort of functions do you see potentially being created in the future as well? Obviously, you've got random number and API. Do you see stuff like maybe zero knowledge proofs as well? Possibly ways of having arbitrary sort of code get run separately and then having it proved later down the line that this has been run and it's valid as well? Is that something you think about?
Could you frame that question again?
Sure. So are you thinking about other sort of like arbitrary sort of functions that maybe developers want to create as well, and having those arbitrary functions run on the network, and then maybe having like a proof function, something like, you know, ZKP, where you can prove that those functions have been run correctly, the output is correct as well? Is that something that is you thinking about with like Boba as well potentially?
Yeah, definitely. That's something that we're looking into.
Cool.
Great question, great idea too.
Quick question. As you have said, because of the API Turing feature, right, there can only be one sequencer. The problem that I see is if the sequencer gets attacked, goes rogue, goes offline, right, this would destroy the whole rollup, correct?
Yeah, that's a more general challenge with today's rollouts in general,
yeah.
Right? Not specific to Boba Turing. So we've already begun our work on distributing the sequencer to address this availability issue, right? And in terms of rogue sequencers, all of the rollouts are going to have to deal with this challenge as soon as we start letting other parties run these sequencers. Now, we are not, of course, going to operate a rogue sequencer ourselves, because that would be shooting ourselves in the foot. We have enough skin in the game to not do that. So the idea would be to extend the same, to ensure that other sequencer operators will have enough skin in the game through staking other mechanisms, that if they do go rogue, there will be severe punishments.
Okay, but this API feature makes it harder, right? So if your EVM equivalent, like Optimism or Arbitrum, for example, to decentralize the sequencer is easier without the API feature, right? Because how would you come to consensus?
Yeah, so we won't be running our own consensus protocol amongst our sequencers. We'll be rotating the role of making Turing calls among multiple sequencers.
Okay.
So at any one time, there's only one that's making that call,
Yeah.
but there could still be multiple instances running.
Okay. Another really quick question. You pointed out the example of the Twitter API, right? So I imagine you have a smart contract, you do the actual API call inside the smart contract, right? You have to put the Twitter API key somewhere, right? And if it's in the smart contract, anyone can see that. How do you handle this stuff?
We do handle it because we have already implemented a faucet that on Rinkeby that requires a user to go through CAPTCHA. And how do we handle the API key? I'll need to get back to you on that. Yeah, to look into how we implemented it.
Thanks.
Yeah, thank you.
Any more questions?
Any other questions? Yes?
Alan, you look very nice today. Did you get enough sleep?
I did, thank you.
Cool. Will you manage through the hackathon? So you get enough sleep, you're okay, you're excited for the rest of the hackathon?
Super excited, thank you.
That's the spirit. Thank you.
All right, well, thank you for coming to this workshop. Please go to bit.ly/getturing, check out DevDocs. Really look forward to seeing you build amazing things on Turing and on Boba. Thank you.